All right, this will be all 12 multiple choice items, module 1 from what, 2015, I believe, what we're calling the 2015 releases. Okay. Number 1, as always, feel free to skip around, skip ahead, but always be ready having already read the question and already attempted it. So, you might very well just be using these videos as flat out answer keys. And that's okay, I guess, just to see if you were correct after trying it first. Number 1, they show you a couple expressions and they ask for which value of x is the value of pi x. I guess you should know that pi, I hope you know this, that pi, there should be a pi button on a lot of calculators, but pi is approximately equal to 3.14. Pi is a number, basically. So let's just kind of approximately equal to it anyway. But we just want to know, like, for which value of x would make pi times x greater than the value of x squared, okay? This is one of those multiple choice questions where not only can you go through each possible choice to check out its correctness, but it's kind of the only way. You pretty much have to just run through all of the choices, and I've kind of put that together in advance, like I've done some calculating in advance. And if you let x equal -2, then pi times x, the pi times x, if you literally just let x equal -2, that value will be about -6.28. And this is something worth pointing out, my goodness. If you are squaring x, if you're trying to figure out the value, for example, of like x squared, and x is something that's negative, then you got to make sure you square the entire -2. If you're just kind of plugging this into your calculator, you better make sure to include the parentheses, or else, because if you're not thinking about it carefully enough and you're just blindly punching buttons on your calculator might tell you literally the wrong answer. So it's very, very, very important to notice the importance of parentheses around this number you are squaring, especially when that number is negative. Because in this case, x squared will get you a +4, all right? And so this is not greater than that. And so it's not A. And we keep going through the choices here. 0 is not greater than 0, it's exactly equal to 0. So equal to is a whole different thing than being greater than. So it's not B, because those are equal, not greater. Choice C, 4.71 is greater than 2.25. But as always, people, you shouldn't just neglect to check D. All right, I mean, just in case, you might have made a mistake or something. So let's check out choice D. And when you plug in 9 for the x's to see if it's greater or not, you get about 28.26. Remember, pi is about 3.14, so this is like 9 times 3.14, and it's about that. And 9 squared is 81, and this is not greater than 81. And so the answer does end up being C. Moving on to number 2. Hopefully this is pretty quick. And again, this is simplifying a square root. All right. Now in this case, I mean, if you go to LaBeouf and you've learned different methods, like I don't know if you understand when I say there's my method that I sort of prefer, and then there's like Mr. Berchanowski's method that he prefers, and they're both good methods. They both work. This one is pretty much referencing my method, the one that's really like very much related to like the actual, I guess, definition or the actual property of a square root, where root 8, you cannot break it up like this. That is not a property of square roots, to break it up by addition or subtraction. This is how you're supposed to, or how, like what the property says, that's how square roots work. That's just like a nature of a square root. Like you're allowed to rewrite root 8 as the square root of 4 times 2, or, and then, well, I guess the property, well, I guess I want to be like technically correct. I guess this is okay to say, because 3 plus 3 plus 2 does equal 8. So I guess I should go back and kind of correct myself a little bit and say that, it's okay to rewrite 8 like that, but it's not okay to rewrite this square root of 3 plus 3 plus 2 as like a couple separate square roots. So I guess that is what is really, really, really not okay. You can't break up square roots like that. But here, if you have the square root of like 4 times 2, you absolutely can break it up into root 4 times root 2. And the reason you'd want to do that is because root 4, you can actually take the square root of, and root 4 is equal to 2. And then you would do 3 times the 2 to get, well, not 12. 3 times what's essentially 2 would be 6. And this here would just stay root 2. So that means A. Number 3, I did a little work in advance to help us out here, because these estimate questions, you really just have to carefully read the question and carefully wrap your brain around it and plan out the math and just, I don't know. There's no reason to get these wrong. There really isn't. Well, there's very little to get these wrong. So, having read this question, hopefully, and attempted it already, you should look at this and go, well, I need to figure out that purchasing 2 sandwiches at that price will total $10.58. 2 burgers at that price would total $13.58. Hold on a second. Hold on a second. Really? For some reason, I just have my doubts there, but yeah, they both end up with 58 cents, don't they? All right, cool. I don't know why I just kind of like got paranoid there for a second, because I saw the double 58s. I was like, whoa, that's kind of a coincidence, but true, I guess. And then 5 drinks for $1.19 each will total $5.95. So total, all of that, $34. So that's what I've done in advance to kind of speed this up a little bit. Next, we would take the $34 and we have to figure out how much was paid in tax. So essentially, we need to figure out what is 8%. Okay, 8% tax. Hopefully, you got to read all of it, and you gotta keep track of everything, and you have to like notice everything, and so we paid 8% tax. So how do we figure out what 8% is of that $34 total? The bill came to $34 total, even, I guess, and we paid 8% tax. So I guess going into the Keystones, it's funny because I don't think they specifically tell, like if you looked up like a list of anchors, like all the different content you got to be ready for in the Keystones. I don't know if they specifically say you have to know how to find percents of things. I don't think they say that. Maybe they do, but I mean, well, you have to, because look here. The proof is in the pudding, I guess, right here. So you have to know how to find, for example, 8% of something, and the way I would recommend you do it is kind of a shortcut. Turn 8% into a decimal by moving the decimal point 2 places to the left, and that has a filler of a 0 right there. So 0.08 is the decimal form of 8%. And you just go ahead and multiply 34 to 0.08, and that's how you find 8% of 34. And my calculator says that that is $2.72. Alrighty. What color will we do next? Purple. But again, if you've read all this carefully, you also know that we paid a tip. That was about twice the amount of the tax. So that means, I hope you understand that that's going to mean 2.72 times 2. And if we multiply that by 2, we're going to get $5.44. So again, it was the $34 bill, the tax, and the tip. And if we add all that together on my calculator, we're going to get a grand spanking total of, just picking my color here, $42.16. So again, these estimate questions, right? Estimation questions. As long as you carefully read it and know about little things like percent, and my advice is don't do any rounding until the way end if you can help it. So considering that my exact answer basically, well, I mean, about twice, whatever, I mean, I just had to consider that doubling it, you know what I mean? So my bestest exact answer I can come up with is the $42.16. And so, I mean, I don't know about you, but to me, I'm going to pick $43 is by far the closest one. C. Number 4. Oh boy. Okay. So this is kind of a classic little keystone thing. Don't be surprised if you literally see something exactly like this, because I think this has popped up in like 2 or 3 of the different years where they released items. So here we go. Here's how you could do it, the fancy way. You could pretty much extend all this out and kind of like do any, I guess, simplifying of all this junk and combining like terms and whatnot and seeing like how all of this would end up matching that. So I'm definitely going to distribute this minus sign first and foremost. And I mean, technically, is there anything to distribute through the first bubble? I mean, technically, there's a 1 here. Just like technically, this is a minus 1. And so, I don't know, distributing a 1 doesn't do anything. Really, I can just drop the parentheses. But distributing this negative or -1 is definitely going to change the signs on all those. So after all that, what I get is minus x squared minus 5x minus 6. And now what I'm going to look to do, and as I utilize this particular strategy, is combine like terms. This term will combine with that term to make negative 3x squared, which, hey, big surprise, right? Not really, actually. And so if we go to combine the wx with the negative 5x, I mean, if that w was a number, we would just combine it with the negative 5 and kind of get this whatever w minus 5 is with the x variable. And then the negative 4 and the negative 6 will combine into, surprise, surprise, negative 10. So over here, we basically need this w minus 5 to equal what? Like, what is the x term over here? Well, it's basically 0x, because there is no x term over here, which means you can pretty much think of it as 0x. So this w minus 5 will essentially have to equal, 0. And what would the w value have to be for w minus 5 to equal 0? Well, 5. Does that kind of make sense? Because the other way you'd pretty much have to do this, unless I can't think of any other way. So the other way I can think of is, again, it's multiple choice. You could plug in negative 8 for w and simplify everything on the left and see if you get negative 3x squared minus 10. And according to what I'm saying, the answer is that would not work out that way. And so then you have to move on to, well, what if I plugged in negative 5 for w? Would that make the left side equal to the right side if w were to be replaced with a negative 5? Apparently it would not. You know what I mean? And then you'd plug in 2 in for w. Again, checking each answer to see which one's correct. That's a big advantage for multiple choice, okay? And then, of course, it'd be, the last one before you strike gold in this case. But anyway, moving on to number 5. Keyshawn buys 100 baseball cards to start a collection. He purchases. Okay, essentially, this question is read the read the paragraph, read everything that's there, and decide which equation models the situation. Once again, the w variable, okay, is filling in for an unknown number of weeks, or like a varying number of weeks, but w is basically number of weeks. And the b variable is a number of baseball cards. So considering that we start with 100 and we purchase 25 more baseball cards each week, okay? So 25 cards every week. Now, to get like a total number of baseball cards, wouldn't you naturally multiply 25 times how many weeks have gone by? But how many weeks have gone by? Well, that's one of our variables, w. So I would think, let me just double check, that this equation makes no sense when you read it as number of baseball cards total will equal 25 cards times the number of weeks which have gone by plus the 100 we started out with. All right? 25 cards per week times the number of weeks. This gets you a total number of cards, and then you got to tack it on to the 100 that we started with. So, yep, I'm going with C. Number 6, another quick one, hopefully. They talk about Lewis doing some math, and you have to identify the property that was used, right? Let me just double check the reading. Which statement is on this equation? Why the double question here? Wait, which statements describe the procedure Lewis used instead of solving the equation and identify? Oh, because they described the adding or multiplying. Yeah, okay. Well, it's definitely which property, right? It's. I hope you can. This should be one of the easier questions, right, on a Keystone exam. I hope you can see that it's the distributive property, but I think they're like literally describing the distributive property. So. It's not associative. So which, is it B or D that, literally describes what the distributive property is? Did we add 3 and x to eliminate the print? No. We multiplied x and 7, or I guess you could think of it as we multiplied x and negative 7 by 3 to eliminate. Definitely D. Okay. Raul has 40. So what you're trying to do here is you're trying to, and again, hopefully I'm going to hopefully make it a habit of not reading the question to you. You read the question yourself and then watch the video. So you're basically supposed to figure out how many days it will take to Raul and Jamie to have the same amount of money. All right, look. One way to do it is to come up with an equation for Raul and an equation for Jamie, where apparently I'm using X as a number of days and Y is a total amount of money, right? I mean, this is what would make sense for Raul, this would make sense for Jamie. And if you want to figure out on what day or after how many days will they have the same amount of money, you could just set those equations equal to each other. All right? And then you would proceed to solve for X, which would mean, get it? Come on, man. What? I thought I just clicked on blue. Not that it matters, but. So remember, people, solving equations 101. I might as well give the whole story, huh? If there's any parentheses to clear, you would probably do that first via the distributive property. Then you would probably look to see if there was any like terms that were already on the same side. You know, if there was already like terms on the left, you could just combine them. Or if there was already like terms on the right. None of that holds here. There's no parentheses, there's no like terms. But we do have an X variable appearing on both sides. That's not going to, that's got to change. So the very first thing we do, or the very first thing I'm going to do, is I'm going to get X only on one side by doing that. Probably going to run out of room here, but that's 20X I do declare. And now that X is only on one side, I'm going to get it all by itself. I'm going to make sure it's the only thing. The letter X is going to be the only thing I want on that right side. So first I'm going to undo that from the right side and get, oh gosh, in my head, zombie. Anyway. And now we just got to do what? I'm out of room. Divide both sides by 20 and get, I do declare in my head, 16. Yeah, boy. So that's the fancy way to do that. Set up a couple of equations, set them equal to each other. But it's worth pointing out here. It's worth pointing out that there's another way to do this, right? Just kind of like make a little day-by-day account of each one's money. That might have been something you thought to do, right? Where you literally, Parks and Rec reference, where you literally keep track of Raul's day-by-day, is it by day? Yeah, day-by-day total money, where, this is basically day 0, okay? I mean, you gotta obviously, don't forget that. This is basically day 0, day 1, okay? After 1 day, they don't match. After 2 days, they don't match. After 3 days, they don't match. After 4 days, and just keep that going. Now, it's a pretty good strategy, but there's, the advantage strategies like this have over strategies like, the purple and green here, is that, look, the final answer ended up being 16, right? 16 days. Would that be the worst thing in the world to have to play this out, like for 16 days? No, but, look, what if the answer was 32, right? What if the answer ends up being like 100 days? You know what I mean? What if the answer is not even nice? Like, what if the final answer is like 7.3 days or something? I don't know. So strategies like this are, hey, they work a lot. I'm not ripping on strategies like this, but there definitely is reasons that strategies like this are, it's hard to argue that strategies like this with the equations are overall superior and more reliable than strategies like this, okay? Hope you understand that, but hey, the strategy would have worked out fine. I guess you just have to go out, 16 days out, I guess, before you finally realize, oh my gosh, they finally match. Next, number 8. Well, this is a compound inequality, and it's a very simple one. All you have to do is figure out which graph, this is about as basic as it gets, man. Which graph goes with x being less than or equal to 3, and x is greater than or equal to 0. Now, it's worth pointing out that when the word is and, well, normally, I might as well give the whole story here. Not the, a lot, well, might give as much story as I can without dragging on too long. But normally when the word is and, normally this double inequality is smushed together like this. Okay, I'm actually sort of surprised that the inequality wasn't given to you like this. So x is less than or equal to 3 right there. X is greater than or equal to 0. Well, in other words, 0 is less than or equal to x. Isn't that another way to say x is greater than or equal to 0? And again, normally when the word that connects two inequalities is the word and rather than the word or, you're going to have a smushed together inequality. And by the way, the graph will almost always be a smushed together graph like this, where they collide with each other. So let's see here. I'm going to go down here to C to start and kind of go, okay, well, x is less than or equal to 3. That's a solid circle because of the or equal to. And that goes that way. All right? Let me just kind of, I don't know. And the x is greater than or equal to 0. Again, it's a filled in circle on the 0. And everything greater than. So, heck, you know what? It looks, and these are going to collide because of the and they're just going to kind of stop and collide. And we're only going to go, because an inequality like this, people, look. Inequality like this can be like translated into x is in between 0 and 3. In between 0 and 3. And again, this or equal to thing, or equal to means including 0 and 3 with the closed solid dot point on 0 and 3. So yeah, it's not going to be anything with the open circles. This means, like, just as an example, again, trying to be very overly thorough. This graph, this graph right here just means x is less than 0. Strictly less than. And this graph over here means x is strictly greater than 3, So when you have a symbol like this, you get an open circle. Symbol like that, you get an open circle. And anyway, probably should wrap this one up. This wasn't that tough. Taking too long. So choice C should be it. Number 9. Patricia keeps apples in 3 bins and 2 crates. Again, please read these things through more than one time. Don't read it once and go like, I don't know what's going on, and then give up. So you should look at this and go, each crate, and kind of get a grip on everything that's being said, all the info. Because we have 3 bins, and each bin can hold no more than 200 pounds. And each crate, and there's 2 of them, can hold no more than 50 pounds. So, I mean, when you look at the graphs and you think about this long enough, and hopefully, I mean, I guess if you're stumped here. But as far as the bins go, 3 bins, up to 200 pounds each. Wouldn't that be 600 pounds from the bins? Well, let's go ahead and use blue again, I guess. So 600 pounds from the bins, because 3 times 200, and then from the crates, 2 of them at 50 pounds each, like no more than 50 pounds in each of the crate. So that'd be like, what the, come on, can I click the new color? So that'd be no more than 100 pounds. So basically, no more than, it's worth pointing out this whole, no more than, man, I'm no more than, so overall we have like basically no more than 700, right? Like altogether it's like there's no more than 700. So we could have 700 or less, you know? Like the words no more than, that means you could equal 700. I mean, that's just the English language, right? So graphically, you know, it looks like we can include 700 with a solid dot, but we could also have potentially less than 700, so the final graph ends up being A. Number 10, having read this already, if not, pause and read this over, because at the end of the day, all they're really doing is they want you to just explain what that literally means. You know, what does it mean to be greater than or equal to negative 196? Well, it means we can be at or above negative 196. So, it should be D. But again, you know, don't blow by, you know, A, B, and C without like double checking, I guess. So, temperature is below negative 96. No, this would have been a less than. Nitrogen is a gas only if the temperature is above. Well, that would have been a greater than for T. You know, T is greater than that. Nitrogen only if the temperature is at or below. That would have been a less than or equal to. So it's D. Number 11, here we go. This is interesting because they want you to do all this reading where, again, you have to know what these variables are representing. And the Y variable is obviously number of long songs, and your X variable is number of short songs. So considering and remembering that X means what it means and Y means what it means, and after doing all of the reading, like for example, the band members want to record no more than 16 total songs. So think about it. If we want to do like no more than 16 songs, could we equal 16? Do we want to, does that mean, you know what I mean? No more than 16. So that means like 16 or less, you know? So I'm going to go ahead and say like it can't be that. You know, look, just less than 16? No, it's not going to be this one, because we want one that says, you know what, wow, I already know it's B. Because, you know, I mean, look, I just know that based on the reading, Y is a total number of songs, or not, well, X is a total number of short songs, Y is a total number of long songs, and when you add them together to get total songs, like grand total songs, it's, you know, no more than 16 means less than or equal to 16. And so these options were very kind. And we already sort of know it's B, but again, just to double check, just to kind of be thorough here and make this extra helpful. 3x plus 5y is less than 78. That also makes sense because 78 was shorter than 78 minutes. 78 was a total number of minutes. And the album has to be shorter than that, which means it can't even reach 78. Like, we can't even be equal to 78. That's why this is a less than and not a less than or equal to. Just because of the verbiage, it needs to be shorter than 78. And it makes sense because 3 is how long each short song is, approximately. And 5 is how long each long song is. So it makes sense to be like 3 times x, because x is the number of short songs, so we would multiply 3 and x together naturally. 5 times y, and again, b. Finally, number 12. Well, this is a good Keystone question. This is a good one to understand. A good system of inequalities question. All right, I like it. So, here's the thing. Based on the reading, I'll do that last. Here's the bottom line. All right, all this information ends up being graphed, and they give you the graph for free. Here's the graph. All right, it represents all the different, it represents Nate's situation, where X is apparently the number of large cans, and Y is representing the number of small cans. You should be able to tell that just from the graph they give you, okay? Just from the graph. Now, what they are asking is, which combination of cans could Nate buy? And I want to make it a point, no pun intended, I want to make it a point to say that choice A, 2 large cans and 6 small cans, that is essentially saying that 2, 6 very well might be like a solution to the system of inequalities that we could have written, But just by looking at the graph, you can tell just by the graph if this point, 2, 6, because again, large cans is x, small cans is y, and so 2, 6, where is that? Look. 2, 6. So is option A representing a combination that Nate could buy? No, because it's not in the what? It's not in the shaded area. So it's not A because of that reason. B, 2 large and 10 small, that's 2, 10. That's like saying, is 2, 10 a solution on the graph? And again, in other words, is 2, 10 in the shading? 2, 10. Ooh, ding, 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 ding. But, so I'm saying it's B. But why not double check? Well, why not check out C and D just to make sure? 6 large and 10 small. So basically, is 6, 10 in the shading? Nope. And 8 large with 2 small, so that's I want an orange. So what is this? 8, 2. So look, we go to 8, 2. Whoop, that's right there. And so, yep, the only one that's in the shaded area is B. And just for a little extra bonus math, some bonus math. Like on a side note, people, the system of inequalities that could have been written, that go with the graph, that you actually could have been expected to write on your own from the reading, at least 10 cans of fishing bait, right? At least 10 total cans, and up to $54. So look at the symbols because of from the wording about spending up to $54 and at least 10 cans total. This, okay, is the system that could have been written, and especially when you solve these for y, you should be able to see that, oh yeah, this is the graph from those systems of inequalities, okay?